Hello everyone. My name is Daichi, and I will give you the lecture regarding the radiation and remediation activities. So, let's start today's lecture. Today's theme is, what is the radioisotope? Are you ready?
Children are playing in the park. They look so happy. But, I see so close resemblance between these three children.
I think so too. They look so similar, therefore they could be triplets. However, if we look so carefully, they have something slightly different with each other.
Yeah, you are right. The number of moles is different between the children. 1 mole, 2 moles and 3 moles, respectively.
Taking this opportunity, today I would like to talk about the fact that elements could have different characteristics, including radioactivity, with the difference of structure of the elements, even if the difference looks so small. Before going into detail, let us just briefly review the structure of an atom. This is an example of an helium atom. There is an atom core in the middle of the atom, and the atom core of helium comprises 2 protons and 2 neutrons. And you can have an image that 2 electrons circulate around the atom core. In order to represent circumstance of the atom, sometimes the atomic number, which is equal to the proton number, is written at the bottom left of the element symbol. In addition, at the top left of the element symbol, the mass number is written, which means the proton number plus the neutron number.
I understand this, because I learned it in school, although I remember it a little bit in a vague manner.
And there are elements which have the same proton number and a different neutron number. In other words, they are exactly the same element, but they have the different mass number. A representative example of the same element with a different mass number is hydrogen. The proton number of hydrogen is 1, and the most dominant atom in the environment is an atom without neutron, which is called the light hydrogen. In addition, there is another hydrogen atom with 1 neutron, in other words, with a mass number of 2, which is called the heavy hydrogen, or deuterium. Moreover, there is another hydrogen atom with 2 neutrons, in other words, with a mass number of 3, which is called the tritiated hydrogen, or tritium. And the atoms, which are the same elements, but with a different mass number, are called isotopes. By the way, the heavy hydrogen and the tritiated hydrogen also exist in the natural environment, although the proportion of the existence is much lower than the light hydrogen. There are other isotopes of hydrogen, but here I would like to focus on these representative 3 isotopes. Amongst them, the tritiated hydrogen, or tritium, has radioactivity, and it is called radioisotope. I would like to elaborate the characteristics of the tritiated hydrogen in another lecture.
Definitely, they are all elements of hydrogen, but they have their own individual characteristic when they have different mass number. By the way, are there any other examples of isotopes? And there seem to be radioisotopes with radioactivity, but don't we need to worry about the effect on our health?
Regarding the impact on people's health, I would like to cover it in detail in another lecture. However, a summary is provided in another lecture, saying that, for example, it depends on the amount of exposure dose, or types of radiation. Please visit the lecture, if you are interested in. And I can take carbon atom as another example of isotope. The proton number of carbon atom is 6, and there are a number of other isotopes of carbon atoms. Here the only representative 3 isotopes are covered, whose neutron number are 6, 7, and 8, in other words, whose mass number are 12, 13, and 14, respectively. These are called carbon-12, carbon-13, and carbon-14, and amongst them, the carbon-14 is a radioisotope which has radioactivity. By the way, I can take the carbon-14, which I have just covered earlier, as an example of utilization of radioisotope. The existence ratio of the carbon-14, within the ecosystem, as well as within the animals and plants themselves, had kept almost in the same level when they were alive. Taking advantage of this, the carbon-14 is used to estimate the era or time when they existed on Earth. This methodology is called radiocarbonating, or radiocarbon chronology, and it is widely used in a variety of fields, including archaeology or art.
I see. The characteristics of atoms sometimes dramatically change, such as radioactivity, even as a result of apparently small difference, like the mass number. And I also understand the examples of application of radioisotopes, used in the fields of archaeology and art.
So, let me wrap up my lecture by providing you the key points. Today I talked about the radioisotope. First of all, radioisotopes represent the relationship of elements, which have the same proton number, but the different mass number, or sometimes represent the nuclides themselves. The radioisotope is the isotope with radioactivity, and the tritiated hydrogen and the carbon-14 are examples of radioisotope. The radioisotope is radioactive materials, therefore, sometimes it may cause a negative impact on people's health, depending on the amount of exposure dose. In addition, I also mentioned that some of the radioisotopes exist in the natural environment, and that some of them are used in the fields of archaeology or art, and so on. Okay, today's lecture is now dismissed. See you next time. In this channel, the useful information regarding the radiation and remediation will be provided to you. If you like it, please subscribe to this channel, and do not forget to click the like button.